Hi, I'm Olivera and I'm going to present to you a project make of ozone detector in the school laboratory that was created on the initiative of my students within the framework of activities aimed at taking care of climate change. For an introduction, something about ozone. Ozone in the stratosphere occurs in two steps. First is the decomposition of molecules of oxygen atoms under the influence of UV rays. In the second step, free oxygen radicals react further with oxygen, giving molecules of ozone. Ozone is found in two layers of the Earth's atmosphere. Most of the ozone, about 90%, is in the stratospheric layer and is known as the ozone layer or good ozone. A smaller part of the ozone is located in the lower parts of the atmosphere in the troposphere and is known as bad ozone. Although they have the same chemical formula, the role of the two ozone is completely different. Ozone in the stratosphere known as the good ozone because it protects the Earth's surface from dangerous UVB radiation. Tropospheric ozone, known as the bad ozone, is created by human activity, and this ozone in the lower atmosphere is harmful, and it is necessary to monitor his presence, and that is what intrigued us and led to this work. The Montreal Protocol protects good ozone, but there is no global agreement that protects us from the effects of bad ozone. Many countries include surface ozone as part of their air quality standards and clean air regulations, so in 2005 the Republic of Croatia also passed the regulation on ozone in the air. On the internet, I found an interesting method of making indicators in the form of strips, so I decided to try to make an ozone detector with the students. With this ozone detector, the students measured ozone in the places where they live, and with this we covered area of Labin. Results we could compare with the official data of the Teaching Institute for Public Health of Istria County. The procedure for making strips in a school lab for measuring the amount of ozone in the air is described here. You will need filter paper for 300 strips, 5 grams of starch, 1 gram of potassium iodide, 1 liter of deionized water, beaker, container with a stopper, scissors, glass plate and microwave oven. To measure ozone, the prepared strip is moistened with deionized water and exposed for 8 hours in a shaded place. For data accuracy, the measurement is repeated 7 days. Every day, the mean value of the relative humidity in the air is recorded. Schonheim number is determined by color on the strip, and then from the diagram, the concentration of ozone in the air is read. With strips, students measured ozone in the places where they live, and with this we covered Labin. The group determines the GPS coordinates of its location and sign in them on the map. On all locations, it is evident that the ozone amounts in Labin area are within the permitted limits, because they rarely exceed the PV, and only once the GV for the measurement period. As data for the Katarina location was available to us, we once again checked the accuracy of the ozone detector by comparing our results with the official results. We have determined that our values are slightly higher than the official values, but good enough to monitor the state of the environment. Through our work, we have shown that it is possible to create an ozone detector in a school laboratory, and thereby enable the monitoring of ozone in the air with much less resources than those required for the purchase of commercial tests for ozone left parenthesis 2,52 versus €687. My wish was to show that with a little goodwill and with minimal funds, an ozone detector can be prepared in every school, which can then be used to monitor the amount of ozone in the air. In this way, students are provided with a research approach to understanding the importance of knowing air quality, which is a problem of global proportions today.